Hello, logic students. Today we're going to do practice problems for Chapter 3, Section 1, Roman numeral 1. In these, we determine whether an expression is well-formed or not. We're going to do the odd-numbered ones, and I will leave the even-numbered ones for you to do at home as practice. Let's look at practice problem number 1. It's R horseshoe G. If R, then G. Is this well-formed or not? Yes, it is. It has just one connective, the horseshoe. There's an antecedent, R, and a consequent, G, and so it's well-formed. We don't have to do anything further. Let's go to problem 3, though. P, x dot y. Is this well-formed or not? No, it's not, because there's no connective that connects the P to the parenthetical expression x dot y. This is called a hanging letter. It's hanging, so it's not well formed. So what we would do is to circle the number of that problem that shows that it's not well formed. If we look at problem 5, what we have is W if and only if either Y or A. Is that a well-formed formula or not? It is. It has one main connective, the triple bar. The left equivalent is simply the letter W, and the right equivalent is the parenthetical expression Y wedge A. There's an open and closed parens, like there should be, and inside of the set of parentheses, there's one governing connective, the wedge. So it is well formed. We don't have to do anything further. Let's take a look at number 7. Here we have H or if J then K. Is this a well-formed formula or not? No, it's not, because we do not have a main connective. The main connective could be the wedge or the horseshoe. What we need is a set of parentheses in order to show what the main connective is. So we would have to have a set of parentheses here or here, but there is none, so it's not well formed. So what we would do would be to circle the number of the problem to show that it's not well formed. That's all you would have to do in this kind of exercise. Let's take a look at number 9. It's obviously a little more complicated. What we have here is x dot y if and only if z implies that k if and only if L. Is that a well-formed formula or not? No, it's not. It does have one main connective, the horseshoe. This is the antecedent. It's got open and closed braces, and yet inside there's not just one governing connective. We've got a dot that could be the governing connective, or the triple bar. We don't know which one it should be. There, within the set of braces here, what we need is a set of parentheses, but we don't have them. So this is an ambiguous expression. It's not well formed. So we would circle the number for it. Finally, in number 11, we've got much taller grass, as I like to put it metaphorically. This is more complicated. What you see here are two sets of braces with brackets inside and even parentheses inside of them. So it takes a little bit longer to analyze, but we can figure this one out. Is this one well formed or not? Well, it's got one main connective, the dot. On the left side, or the left conjunct, we've got an open and closed brace, like we should. Inside of the braces, there's one governing connective, the dot, that connects the left conjunct, not U, to the right conjunct, which is a bracketed expression. Inside of the brackets, we've got one governing connective, the horseshoe. In the antecedent, we've got a parenthetical expression. We have an open and closed parenthesis like we're supposed to. Inside of it, there's one governing connective, the wedge, that connects the left disjunct V to the right disjunct, not W. Notice that the tilde here is negating the W. They're acting as a unit, like a negated number in math. So that's perfectly well formed so far. Let's go over to the right conjunct now. We've got a tilde on the outside of the set of braces. That's perfectly legitimate. Inside of the braces, we've got a bracketed expression, and it as a whole is negated. That's also perfectly legitimate. But if you look inside of the brackets, what you see is a set of open and closed parentheses, and inside of the parentheses, there's not one governing connective. There's a dot and a wedge. So this is an ambiguous expression. What we would need here is to have one of those parentheses moved over, but we don't know which one or how, and so this one is not well formed. The problem is right here. So this one also would be not well formed, and we would simply circle the number. Okay, these go from easier to harder, like all of my exercise problems, but if you take it one step at a time, even the hardest one is not that bad. The even-numbered ones are left for you at home. Okay, now what we're going to do is the exercises that are Roman numeral 2. This is also beginning on page 210, and these go for quite a while. This is a very long set of exercises, but they begin on page 210, and these are exercises that relate to translating a statement from natural language into our symbolic language. Let's take a look at number 1. Here it says, inflation is not on the rise. And in the parentheses, we're told that I symbolizes the expression inflation is on the rise. You'll always have inside of the parentheses all of the simple statements and the capital letters that represent them. So in number 1 here, if I means inflation is on the rise, how would we translate inflation is not on the rise? Correct. What we would do is to put a tilde in front of the I, not I. This means inflation is not on the rise. So it's just like in math when you want to negate an expression, what you do is to put the tilde in front. You would never have I tilde. This is meaningless garbling. So this would never be correct. It could only be tilde I. Let's take a look at another one. Let's try number 2. Here we have that Y means there are 365 and a quarter days in the year, and W means there are 7 days in a week. So how would we translate into our symbolic language the compound expression, there are 365 and a quarter days in a year and 7 days in a week? Right, we would have Y dot W. Now, by the rule of commutativity, what we could do that would be equally okay would be W dot Y. That's also perfectly legitimate. Okay, now let me show you a technique here in case this is already a little bit intimidating for you. This is called the strike-through method. It's not in the textbook per se, but I'm giving it to you now. Let's say that we have this statement. There are 365.25 days in a year, and there are 7 days in a week. To use the strike-through method, what we would do would be to take each one of the capital letters that we have, and for every occurrence of it, we would strike through that expression and put the capital letter above it. So here we would strike through this and put Y. Then we would strike through this expression and put W. All that would leave would be this word and. Now we have to use our symbols to represent this conjunction. The word and is always going to be represented by a dot. So we put a dot up here, strike through there, and here we have the answer, Y.W. That's called the strike-through method. It can help you early on in solving these problems. But after a while, once you use it, then you sort of wean yourself from it and say, I don't need to do that anymore. I understand it. I can just simply circle the logically functioning words, and that's just as good. But this is sort of an aid for beginning. Let's take number 3. Now, on this one, U means ultimate knowledge is possible, and S represents the statement the search for truth is important. So if we have the compound expression, if ultimate knowledge is possible, then the search for truth is important. How would we represent that? Correct. We would have U, horseshoe, S. If U, then S. Now notice that when you have a horseshoe, you cannot turn it around and still get a logically equivalent answer. So here, S horseshoe U would not be correct. The only way to have a correct answer here would be U horseshoe S. Again, that could be done by the strike-through method very easily. Let's go over now to number 5. Here we have P representing the simple statement, he will win the prize, and H represents the statement, he will have to try harder. How would we represent the compound statement, either he will win the prize or he will have to try harder? Correct. It would be P wedge H. Either P or H. The wedge represents the disjunctive phrase either or. Now, by the principle of commutativity, it would also be okay to answer H or P. These mean the same thing. But this is going to be more natural to you to take it in the order that the statements are given in the compound statement. Again, the strike-through method could be used there easily, and all you would have left would be the words either and or, which you would then represent by the wedge. Moving down a little bit to number 7. Here we have the simple statement, the defendant should be found guilty, is represented by capital G, and the simple statement, he can be connected to the murder weapon, would be capital W. So how would we represent the compound statement, the defendant should be found guilty if and only if he can be connected to the murder weapon? Right, it would be G triple bar W. The defendant should be found guilty if and only if he can be connected to the murder weapon. Now, an alternative way to do this would also be W triple bar G. Again, with the triple bar, we can commute around the two sides without any loss in meaning. It's only the horseshoe that we cannot reverse the order and have the same meaning. Okay, let's crank it up a notch and go to number 8. This now has 3 simple statements in it. L means the Libyan revolt will succeed. N means NATO will lose face. And S represents the simple statement the Syrian government will be intimidated. So how would we represent the compound expression? Either the Libyan revolt will succeed, or NATO will lose face and the Syrian government will be intimidated. Well, I think that you can see that the order of the letters and the connectives would be L, wedge, N, dot, S. But that's not a well-formed formula because we don't have one main connective. So we've got to have a set of parentheses to give this one main connective. But where do we put the parens? Would they be here, or would they be around the N and the S? There is no way to know except for punctuation. The moral of the story in number 8 is that punctuation matters. Every one of my practice exercises has some sort of moral to it, if I can put it that way, a logic moral. And in this one, it's that punctuation determines what the expression really means. Now here, the punctuation is that comma, and it occurs right here. The comma is what breaks the compound expression in half. So the wedge is the main connective. The N and the S go together. And it's the comma alone that tells you. It breaks the ambiguity in the expression and tells you exactly the meaning of the compound expression. That was a little bit harder, but not bad. Let's go down maybe to number 13. And here we have an expression only if. This is going to be your first occurrence of only if in the practice exercises, and it is especially important to take note of. In number 13, we have 2 simple statements. M means mental exercise benefits brain health, and P means mental exercise is paired with physical exercise. Now, the meaning of only if is that it's a necessary condition. The phrase only if means that a necessary condition follows. So here, what we would have would be M, horseshoe, P. P is the necessary condition, and so necessary conditions always go in the consequent spot, whether they're given first or last grammatically. We're not worried about the surface grammar level. We are only worried about the deeper logical structure. So you can think of this one as saying M only if P. Only if you think about how you use that expression, only if, it's always giving a necessary condition. For example, I'll go to the party only if I receive an invitation. Receiving an invitation is the necessary condition for me going to the party. Okay, so we have to be able to distinguish necessary from sufficient conditions, and that is gone over in some detail in the book that you can refer back to if you don't remember. Now, one issue here that you're going to see right away is that only if sounds like if you're reading quickly. If and the expression only if have different meanings, though, from a logical point of view. They're completely different, really. So you have to be reading very carefully. Only if is always going to give you what comes to the right side of the horseshoe expression. We'll come back to this numerous times. The expressions around the word if are very important, and there's quite a few of them. So we're going to go over them in detail, and I also have modules on the course page that go into that particular topic as well. Now let's look quickly at number 14. Now we're on page 212. The simple expression, you light the fuse, is represented by the letter L, and R represents the simple statement, the rocket will launch. In this one, we have, if you light the fuse, the rocket will launch. How would we translate that into our symbolic language? Right. L, horseshoe R. If L, then R. Okay, the horseshoe is simply translating our expression if then. Comparing that to number 15, we get a very important logical moral here. Here the expression is the rocket will launch if you light the fuse. So what it's saying is R if L. Notice here that the if and then grammatical clauses from number 14 have been switched around in order. We've reversed the order of the grammatical clause. But that doesn't change the logical meaning of it. The logical meaning of R if L would still be if L, then R. And so the translation in 15 would still be L, horseshoe, R. The same as number 14, even though the grammatical clauses have been reversed. Again, we don't care about the grammatical structure, surface structure. What we're only interested in is the deeper logical structure. Okay, let's try number 18. Morality has a value only if the human will is free. Here, M represents the simple statement, morality has a value, and W represents the simple statement, the human will is free. Now, in this one, what we're doing, if we can sort of do the strike-through method here, is M only if W. Now, only if does not mean if. Only if, again, is giving you a necessary condition. The necessary condition here is W, And so it's going to always go to the right side of the horseshoe. So here we would have M, horseshoe W. We cannot reverse around the order around a horseshoe and still keep the same meaning. So this is the only possible translation here. It's important to compare 18 to 19 because it has the same simple statements, but now the surface grammar structure has been reversed. Here we have only if the human will is free does morality have a value. Let's sort of use the strike-through method here. Say only if W, then M. Only if, again, is going to represent or signal a necessary condition. And so that simple statement will always go to the consequent spot or the right side of the horseshoe statement. So this one, again, like 18, is going to be M, horseshoe W. Even though W is given first at a grammatical level, it is a necessary condition, so it absolutely must occur in the consequent spot to the right side of the horseshoe. Okay. Now, let's try a few more, taking a look quickly at number 20. Here, P means Pakistan will follow the lead of Saudi Arabia, and Q means Qatar will follow the lead of Saudi Arabia. So how would we represent the compound statement, both Pakistan and Qatar will follow the lead of Saudi Arabia? This is a little bit harder than some of the earlier ones because now we've got both and. This is what's called a multiple predication. You don't have to know that term, but that's what it is. If you think about it, even for just a second, what this compound expression means is that Pakistan will follow the lead of Saudi Arabia and Qatar will follow the lead of Saudi Arabia. So its answer, its translation is Q, or P rather, dot Q. Now, by the principle of commutativity, again, we can switch around the left and right side without any loss of meaning. This would also be okay. Q dot P, they mean the same thing. So either one of those answers would be counted as correct. Now let's go to 21. It has an important moral because we've got a word here that we need to figure out the meaning of. And that's the meaning of the word yet. What logical function does the word yet perform? Looking at 21, we see that B represents the simple statement, Belgium will sign the accord. And G represents the simple statement, Germany will decline. And in the compound expression, we've just stuck in the word yet between them. So we've got Belgium will sign the accord, yet Germany will decline. So we've got the two expressions B and G here. Now we have to figure out which connective represents the word yet. And here, what you can do is to ask yourself what you mean as a rational thinker and a user of English natural language when you use the word yet. Do you mean that it's not true, which would be a tilde? Do you mean both of them are true, which would be a dot? Do you mean at one or the other is true, which would be a wedge? Does yet mean that they're conditional, which would mean a horseshoe, or that they're biconditional, which would be a triple bar? When we use the word yet, we mean both of them are true. So what we mean is Belgium will sign the accord and Germany will decline. Both of those statements are true, and that's what the dot means. The dot means both of these statements are being asserted to be true. And of course, by the principle of commutativity, reversing them around or commuting them around the dot would be perfectly okay. That has the same logical meaning, even though the surface grammar structure is different. We don't care about the surface grammar structure. Let's move on. Let's try 22. Again, we have three simple statements. I, meaning Ireland, abides by the agreement. E means England abides by the agreement. And C means there will be a conflict in the north. So how would we represent the compound expression, both Ireland and England abide by the agreement, or there will be conflict in the north? One way that we can do this is to put down the order of the letters. Ireland, I, England, E, and conflict, C, and then put in the connectives. Looking at the first compound, we have both Ireland and England abide by the agreement. That goes back up to number 20, where we learned about both and. Both and is going to be represented by a dot. So you'd have a dot between I and E, and then between E and C, we have the word or. That's going to be represented by our wedge. So here we've got the basic order and flow of the simple statements and the connectives. But it should be obvious to you, this is not a well-formed formula. We've got two connectives here. We don't know which one is the main connective. So how do we solve this one? Again, this one is going to go back to punctuation. It is punctuation alone that will determine where we put the main connective. That goes back to exercise number 8. If you look at the punctuation here, you see that the comma is occurring right after the E. The comma shows that the expression breaks in half at the wedge. And so we show that by putting parentheses around the I and the E. This now makes a well-formed formula that exactly communicates the meaning of the expression in 22. Notice here that if we had I dot open parens E wedge C close parens, this means something different. They do not mean the same thing here. Okay, so it's absolutely crucial to make the main connective properly, accurately, and to put the parentheses in the right spot. Okay. Now let's go further to number 23. This one has a little glitch. It seems very simple, straightforward, and short. But again, as I always tell you, in logic, the short problems are frequently harder than the long problems. This one, you have to pay attention closely to what the letters mean. Looking at the top of page 213, for number 23, we see that L means life has meaning. And X represents the simple statement, true love exists. How would we translate the compound expression, either life is meaningless or true love exists? It seems rather easy, doesn't it, that what this should be is L wedge X, but that's not right. This is not a correct answer. What does L mean? L means life has meaning, But the compound expression is either life is meaningless, in other words, that it doesn't have meaning. So the L has to be negated with a tilde. This is the correct translation, not L or X. Now, there's a couple of things that I can point out here by the principle of commutativity. It would be okay to reverse the order and say X or not L as long as you've got the L. But it would not be correct to have a tilde on the outside of a set of parens and put this inside of the parens. This means something different. We'll see later in the next section that what this tilde is negating is the wedge, not the L. But in the compound expression, the tilde is negating the L. Okay, so this one's a little bit harder, even though it seems easy. And what we had discovered there as the logical moral, so to speak, is that sometimes a negation can occur as a suffix. That suffix less means not having meaning. Looking at 24, this one is also relatively short. What it does, again, like number 21, is to revolve around a word that may be less than obvious to us, and that's the word unless. What is the logical function of the word unless? Well, let's look at the problem. We've got two simple statements. S is going to mean we lead shallow lives. And A is going to represent the simple statement we seek authenticity. The compound expression is we lead shallow lives unless we seek authenticity. So we've got S and A. But what does the word unless mean? Again, the best way to do this is to ask yourself the question, when I use the word unless, what do I mean? Do I mean that it's not true, which would be a tilde? Do I mean both of the statements are true, which should be a dot? Do I mean one or the other is true, which would be a wedge? Do I mean that one is conditional on the other, which would be a horseshoe? Or do I mean that both of them are conditional on each other, which would be a triple bar? Well, if you think about it, the word unless means one or the other. So another example might be, I'll go to the party unless there's something good on TV. What that means is either I'm going to go to the party or there's something good on TV. Unless is going to be a wedge. So we put it in now. S wedge A is the correct answer. Again, by the rule of commutativity, you could have A first and reverse the order around the wedge without any loss of meaning. And that would be a perfectly legitimate answer. Let's try 25. This one also is sort of what I'd call a speed bump problem. It doesn't look hard, it's short, but there's one little glitch that you must see to get the answer right. In 25, we have two simple statements. L means life has meaning, and C means we must create our own meaning. The compound expression is, if life has no meaning, then we must create our own meaning. Now, at this point, I think you should be able to see that the main connective is going to be the horseshoe. And it's going to represent these words if and then. Okay, now, if you look what occurs between the words if and then in the compound expression, it's that life has no meaning. But what does L mean? That life has meaning. So to represent life has no meaning, we have to negate the L. So we have tilde L here, and then what occurs after the word then is simply the statement C. So the correct translation here would be tilde L horseshoe C. We don't need parentheses because this tilde is just negating the L and nothing further. Its range goes only across the L. So an incorrect answer would have a tilde on the outside of a set of parentheses like that. That means something completely different. So this is not an accurate answer. This would be the only straightforward translation. Although again, by our rules, there's really an infinite number of different possible correct translations. This is the most straightforward, simple, and intuitive one. Let's go down now to 28. Here we have two simple statements. Norway signed the treaty, that's N, and S represents Sweden signed the treaty. In 28, the compound expression is Norway, along with Sweden, signed the treaty. So now we've got another compound predication, like 22 and number 20. So we have to ask, what does the expression along with mean? We've got N for Norway and S for Sweden. The compound expression means Norway signed the treaty and Sweden signed the treaty. Along with just simply means both and. And so we would use the dot. So the proper translation would be N.S. By the principle of commutativity, you could also have S.N without any change in meaning, even though the surface grammar structure would be different. We do not care. Okay, let's continue on, and we'll go now to a somewhat easier one. These practice exercises in 3.1 do go in cycles. They go from easier to harder, but then a new cycle kicks in and you get another easy one and builds up to a harder one, and then easier ones kick in. Let's go back to a somewhat easier one, number 29. Here we have just one simple statement. G means the government can be held responsible for the incident. So how would we say the government cannot be held responsible for the incident? We would simply negate the G, tilde G, and we're done. Notice the tilde always has to be in front of the G, just like a negation sign always has to be in front of a number in mathematics. Now 30 has three simple statements, but it only has one minor flourish to it. We can work through this and just take it one step at a time. The simple statement, justice perishes, is represented by the simple letter J. The statement, righteousness perishes, will be represented by capital R. And the simple statement, human life will still have value in the world, is represented by H. Now, here, what we have, I think everybody can see, is if J and R, then, and here's where we have to look closely. H means human life will still have value, but the compound expression reads human life would no longer have any value. That would be the negation of H. So we would have tilde H. This would be what we would arrive at using the strike-through method. Then, I think everybody should be able to see at this point that the main connective here will represent this expression if-then. That would be the horseshoe. What occurs between the words if and then is a compound J and R. How do we represent J and R? Well, J dot R. And we need to keep them together as the antecedent, so we'll put a set of parens around them. What comes after the word then and going to the right side of the horseshoe is not H. So we put not H here, and that's the entire expression. This is a well-formed formula, and it perfectly reflects the meaning of the compound expression. The glitch here is that you have to see that negation word no longer is thrown in. So one way that you can do that is to circle the logically functioning letters or words rather and make sure that they get represented. Let's try 31. It has one little complication to it. Here we have two simple statements. J means justice would cease to be justice, and B means justice is bartered away for any consideration whatsoever. Now, how would we represent the compound expression justice would cease to be justice if it were bartered away for any consideration whatsoever? We can use the strike-through method, and what we would find here is that we would have J if B. J if B. What does that mean? Grammatically, we can switch this around and see that means if B, then J. The if occurs second grammatically, but from a logical point of view, it's still in the antecedent. So now it's simple. If B, then J, B horseshoe J. What we cannot have is J horseshoe B. That means something entirely different. Okay, so here the glitch was to see that the order of the clauses had been switched around and that we had to be careful as to what the antecedent and the consequent were. That was a harder one. Going up to 214 here, number 33. If God does not exist, then all things are permitted. G means God exists, and P means all things are permitted. Now, it's pretty obvious that the main connective here is going to be the horseshoe that represents the phrase if then. And what we see is that the antecedent, what occurs before the horseshoe, is God does not exist. But G means God does exist. So how would we say God does not exist? Tilde G. And then, of course, in the consequent position is simply P, all things are permitted. So this one would be not G, horseshoe P. It's, again, the glitch is a negation word that is not going to be all that obvious. We have to read carefully. One of the great values of studying logic is it improves your reading comprehension, your reading ability. You have to slow down, read more carefully and analytically, but your comprehension is much greater as to what the expression actually means. Here, the main way to go wrong would be to put a tilde on the outside of a set of parentheses like that. That means something different. Okay, now that finishes really the kind of the first half of the exercises.